Okay, in this segment, I would like to feature a mod. And I think it's fair to say that this would classify as a modification. And for my talking purposes, I'm going to use our familiar and simple tube preamplifier. And this modification is for vacuum tube circuits. Most any preamplifier and pretty much every amplifier that I can think of, with maybe one or two exceptions. This pretty much, I don't think, I'm not the master of solid state at all. I can do a capacitor swap like nobody's business. But anyhow, let me get on with the getting ons here. Just a few of these little note cards that I've prepared here for talks such as this. Okay. V1 plate feeds grid of V2. V1 and V2 are actually two different halves of the same tube on here. But regardless, the circuit does not care. Most every plate has a plate resistor. In every previous stage has one. The significance of it in the DC realm is that it's not terribly significant other than to trim out the voltage. But as we've discussed or tipped upon in my other videos, most of my other videos, in relation to the preamp, we've discussed or mentioned the significance of the plate resistor. And you know what kind of makes it interesting is that it affects the AC signal as well. Okay, and that is in every multi-tube amplifier or preamplifier. They are, after all amplifiers. Anyway, but not at the first go. You have to have a previous stage. This will become relevant in just a second. So typically your volume would look like this, and I call this R1 and R2. A lot of other people call it R1 and R2. When this is on the front end of your amplifier or preamplifier, or when this is on the front end of your preamplifier or amplifier, they are in effect the same thing. What you have is R2 to ground and R1 to grid, with no previous stage other than the previous component, the latter stage of the previous component. Okay, that should all make sense, I hope. Okay, I'm going to start to get a gander at our power supply. The simplest of simple power supplies, and don't, by the way, just as this circuit, don't assume that simpler is somehow weaker or performs in a lesser manner. That is absolutely not true, and throughout audio. That's a fact. But to stay on point, let's look at the AC factor about this. All right. What it is, in fact, is an R2, even though it lies on the B plus rail, and it is not instead strapped to ground. It's strapped to B plus. It is still the grid leak for V2. And if V2 was feeding V3, so on and so on and so on. In this type of circuit, where there are no interstage transformers, which is most vacuum tube circuits. That's a grid leak resistor. So for one thing, its significance in terms of its value determines your input impedance of this stage. But what is that? Well, in the simplest manner, this could be a volume control, or it could be stepped attenuator positioning. Would change the values of each of these, obviously, or either of the two. It's a relationship and how they work. But R1 is known as the grid stopper. And it kind of applies the brakes to what's going through to the grid, if you want to look at it that way. And that is kind of the right way to look at it. It can be a volume control. It can be a suppressor, a noise suppressor. It can be that, or it can be that. R2, and on a standard volume control, by the way, R2 is a fixed value. You don't think so. I didn't think so for years until I started using a voltmeter. It's a fixed value. That is your input impedance, give or take whatever the tube does to the impedance, because it parallels a little bit of resistance. At any rate, it's a very high resistance, I believe. Just how high, I couldn't tell you off the top of my head. That's irrelevant to this discussion. Okay. R1, R2. R2 is the grid leak. If you increase that value, it will make things louder down upstream. If you make this larger, it will make things louder. It won't increase your power or your ability to amplify, but at this position, it will make it louder if you change this value and leave this value alone. So, and if you lessen this value, as others will explain in terms of how to look at this, it's like a voltage divider to your signal, your AC signal. And so if you lessen this value, it gives an easier path to ground. Therefore, more of your signal dumps away, drains away, leaks away, and does not make it to the grid. Or you could say it's attached to the grid and it encourages the electrons to flow that way and cast their image on the grid and then leak away. However you choose to view that, R2 is critical to the flow of your signal into the grid. And when I say it's critical, I'm not playing around here, okay? It really matters. Well, your R2 in all of your latter stages of amplification that is your grid leak, and it does in fact reside on B+. And you say, well, how does that signal find its way to ground? It finds its way to ground at this node right here. These are internodal resistors, and when it pairs up with a capacitor, it creates a node. At any rate, R2 is your grid leak, and it does in fact sit on the B+, and it is in fact leaking your signal away, and it is in search of a ground, and it is going to find one. DC cannot do this, but AC does it pretty easily. You know how AC can go through a capacitor, but DC cannot? A series capacitor? That's what you have on your power supply. And you'll go around for years, maybe, like I did, thinking, well, that's just how much horsepower you have back here. That's just DC power. we're talking about here. It's a power storage device. Yeah. But that first one right there especially, and I believe that they leak on down this way a little bit more. Maybe the last 3% of things. But since it can go through this capacitor, it finds ground right there. Let's take a pause. Okay, I had a little cutaway on this one. We've got storms in the area, pretty bad ones. So I had to duck away for something, but now I'm back. Okay, so we were just talking about the plate resistor, and it in fact is the grid leak resistor. It resides on B+, and it finds its way to ground at the end, or the beginning, however you choose to look at it, of your power supply. Okay. Remember how we also talked about, or you may already know about, what a fuss people, time and money that people spend on fancy coupling capacitors, and how eliminating a coupling capacitor, in fact, can improve the overall sound of the circuit, because if you can get away with it, because of its influence on the AC signal. Okay, so AC doesn't really have a problem going through it, but while it goes through it, the value of that capacitor, the type of capacitor, and everything else about that capacitor has an effect on the audio quality of your signal. It's going to make some subtle changes. And for the most part, it will siphon away, depending on its value, it will typically siphon away either of the extremities of your signal. So low end or top end. But don't assume that there's no little mid-bass bumps or takeaways of things of that nature that it might do to your signal. But it will degrade it. Even the highest quality of capacitor will degrade that signal. Okay? And now we get to the point of our little discussion here. This mod is a simple one. It makes you think. But this is how it works. That is typically an electrolytic capacitor. 9 times out of 10, it's going to be one. I don't have too many in my system. In fact, I have one of my amplifiers, not one of my preamplifiers. My phono preamplifier right there has electrolytics. Everything else in my room functions without them. And that's a good thing. Now you pay for it in terms of, well, you have less capacitance. But here's one of the things that crappy capacitors, which is what all electrolytics are, the dielectric value of what's in between, what is sitting on your DC, is not good. It's bleeding a lot back and forth. That's why they sound warm. They can quiet things down, and they can store a lot of voltage. But it's not the best thing to run your signal through, which is what you're doing. It is the grid leak. And what you're taking away from that signal that's going forward, what you decide to pull away, whether it's amplitude alone, or it's got some other influences on it. Regardless of how you do that, it's going to influence the sound. And what we want to do is create a good ground, an AC ground, right here. We don't need to do it so much here, not so much here, but right about here, exactly, is where we want to do it. And do we have to go tearing everything apart? Do we have to destroy our audio jewelry and take the case apart and well, yeah, sometimes you got to do that, but it's always worth it. You always learn something, even if you screw up. I'll throw that out there. But anyway, I think most of you, even if this is foreign to you, I think that most of you can locate the power supply, and I think that you can determine what the plate resistor is and where that is, and that will give you a good clue, because it should send a wire back to your power supply. Or it could do like I hate, which is to take the plate resistor and have it poking out here. Okay. And now bigger amplifiers and stuff like that may have a series. In fact, they will. They'll have a series of plate resistors, all being fed by B+, and each one spidering off to the tube that it's associated with. But each one is, in fact, a grid leak resistor as well. Grid leak affects the signal, and it affects the smoothness of the symbol as well, because it affects the relationship to R1. So any change at all here affects not only the relationship with R1, but how smooth your signal travels. Don't think this is a small modification. This is a biggie, and it's so simple. When you hear what it will do, I think you'll perk up and you'll say, dang, I didn't know it was going to be like that. So give it a try. All you have to do is get your soldering iron out and a quality. It can be a small value. It can be almost any value you choose. I would choose a value over one microfarad. It can be 5, it can be 10. But get a good quality capacitor. And simply sister it up with the last capacitor on the end of your power supply, right at the node. Quality capacitors, by the way, don't care which is ground and which is your positive, okay? So don't worry about plugging it up backwards. It's not going to matter. You're going to be dealing with some kind of poly, film capacitors, or oils, all of which are bipolar. So you just come in here and all you need to do is find ground. That should be pretty easy. And then you locate that node. You throw a little devil in there of decent quality, like that little paper and oil right there would do it for some circuits. Make sure that it can withstand the voltage. You need to be about 50% over is what I like to be in terms of power handling. So if you know you're sending 300 volts through there, you want a 400 volt rating on that capacitor. But other than that, that's the only thing that really sticks out as far as a cautionary something about this mod. Be careful, and also always remember that when you've powered up recently, these things store power. And just because you unplug it or turn it off, do not assume that everything inside has lost its charge, because it in fact has not. Unless you have bleeders on the circuit or a sufficient amount of time has gone by, especially with big electrolytic capacitors. They'll store enough to stop your heartbeat. So don't do that. But give that mod a try and see if you like it, and give me a thumbs up sometime if you do. And we'll see you in the next segment.